In our last couple lessons, we figured out why the binomial theorem is true. Now we're going to put it to work. And we're going to put it to work by raising some other binomial, something other than x plus y, to the third power. We're going to take 3r plus 2s to the third power and multiply it out. Now we could use the distributive property. Multiply 3r plus 2s times 3r plus 2s, multiply that all out, and take that result, multiply it by 3r plus 2s again, crank and crank and crank. And eventually we'll come up with the, well, hopefully we'll come up with the right answer. We don't make some mistakes along the way. But, well, there's no point in us developing this nice, clever little formula that gives us a bit of a shortcut if we can't use it. So let's try using that instead. Well, now we're cubing something here, so let's go ahead and write the binomial theorem down for when we're cubing x plus y. And we got x plus y cubed, so n is 3. We just put in 3 in this expression. We have 3 choose 0 x cubed, and we've done this a couple times already. And now we're going to use it. Now, all we're doing here is replacing x and y with 3r and 2s. So there's no difference between raising x plus y to the third power and raising 3r plus 2s to the third power. In both of these, we're taking the sum of two terms and raising it to the third power. So all we have to do is replace x with 3r and y with 2s. And we'll just replace x and y over here with the 3r and 2s. Because this works for any x and y. Any x and y. So all we're doing is saying, okay, let's let x be 3r and y be 2s. And let's see what happens. Just putting 3r in for x. Again, we put in 3r for x. And we put in 2s in place of y. And all we're doing here is just using our formula. We proved this formula was true. And now we're just plugging 3r and 2s into it. And there we go. And now it's just arithmetic. We'll go ahead and compute all of these. 3 choose 0 is just 1. And then 3r cubed, that whole thing cubed, gives us 27 times r cubed, because we have to cube both the 3 and the r. So this 27r cubed is our first term. Then here, 3 choose 1, well that's 3. 3r, that whole thing squared, gives us 9r squared times 2s. And then here we have 3 choose 2, that's 3. 3r, and then the product of 2 and s, when we square that, we have to square the 2 and the s, we get 4s squared. And then at the end, well, 3 choose 3 is just 1. And 2s, when we take that whole thing and cube it, we get 8s cubed. Now we just multiply out these two terms, and then we are finished. 3 times 9 is 27, times 2 is 54. R squared s. 3 times 3 is 9. 9 times 4, 36. 36 rs squared, 8s cubed. And there we are. We take 3r plus 2s, we cube it, we get this. And we can test it. We can test it. We can test it by choosing values for r and s. This has to be true for any r and s. 3r plus 2s, when we cube it, we get this down here. And we test it by picking easy values, right? Because we like easy, we like to make things simple on ourselves. So let's see, I'll try one easy value, just see what happens if we let r equal s equal 1. All right, let them both be 1. Here we'll have 3 plus 2 cubed. We'll have 5 cubed. And then over here we'll have 27 plus 54 plus 36 plus 8. Let's see, does that work out? 5 cubed is 125. Over here, 54 and 36 gives us 90. 90 plus 27 is 117, plus 8 is 125. Sure enough, the two sides match up. Let's try another one. Try another one to check our work. Let's try r equals 1 and s equals -1. And why did I choose those? Well, when we put them up here, we get 3 minus 2. That's just 1. 1 cubed. That's easy. We like easy. We put these in here. Well, it'll be 27. This will be minus 54 because s is negative 1. And then this will be plus 36 because the negative 1 gets squared, turns into a positive. That's another reason we're picking 1 and negative 1. They're easy to raise to powers. And here, negative 1 cubed is negative 8. So let's see, does this come out to 1? 27 minus 54, it's negative 27. Negative 27 plus 36 is 9. 9 minus 8. That's 1 all day long. So it works for r equals 1 and s equals negative 1. We can be pretty confident we're right here. Pretty confident we have the right expansion. So that just gives us a nice little way to test our work. Now when I'm doing these problems, I don't do this. I don't write out the binomial theorem for n equals 3. I don't even write this down, but I'm going to leave that up there so you know we're dealing with the binomial theorem here, and it's nice to see that. But I don't write this down. Don't write it down at all. In fact, I don't even have that in my mind. I'm not even thinking of this. What I'm thinking of is how I proved the binomial theorem. I'm thinking, what is 3r plus 2s? Well, it's 3r plus 2s times 3r plus 2s times 3r plus 2s. And I think about our counting proof. What do we do here? When we multiply this out, we take every possible combination of taking one term from each of these binomials. So I get a 3r times 3r times 3r. It's my 3r cubed, and I can only get one of those. I'm not choosing any 2s's. I can also choose 3r twice and 2s once. That'll give me 3r squared times 2s. But I can do that in more than one way. There are 3 choose one ways to choose the 2s. I can choose the 2s here, I can choose this one, or I can choose this one. So I'm going to get 3r squared times 2s 3 choose 1 times when I multiply all this out. Same kind of thing over here. I'm going to choose a 3r, and twice I'm going to choose 2s, 3r times 2s squared. And how many ways am I going to get that? Well, I can choose 2 of the 2s terms in 3 choose 2 ways. These two, these two, these two. So I'm going to get that 3 choose 2 times. And of course I get my 2s cubed. I can only get that one way, by choosing 2s from all 3 terms. So I just write this down. I just think about our approach to proving the binomial theorem. I'm basically proving it over again for n equals 3. I'm not actually doing any new work or anything. I know why the binomial theorem is true, so I can just write this down. I don't have to memorize this. I don't have to write it down and then stick stuff in. All I'm doing here is thinking about why the binomial theorem is true. Out pops the answer, and then we can just crank through the algebra. Now it's your turn. All right, now what I'm going to do here, I'm going to give you one to work on yourself. And then you can watch the next lesson. But don't watch the next lesson until you try this on your own first. All right, here we go. You're going to expand this 1 minus 3b squared, and we're going to raise that up to the 4th. All right, and I want you to go ahead and write down, figure out what the expansion is, expand it all out, and then I want you to test it. You saw how we tested the other one. We picked r equals 1 and s equals 1, and then we tried r equals 1 and s equals negative 1. Do the same thing here. Write out the expansion, figure out what the expansion is using the binomial theorem, better yet, using your understanding of the binomial theorem, and then pick some values of b. Put them in here, put them in your expansion, and see if they're the same. If you do that a few times, for a few different values of b, and they're the same, then you're probably right. If they're not the same, then you have to do the expansion again.